Hello children, today we will be starting chemical bonding. These are the topics we will be covering, and today we will be covering electrovalent bonding only. What is electrovalent bond? The other name is ionic bond. Atoms of metallic elements that have 1, 2 or 3 valence electrons can lose electrons to atoms of non-metallic elements which have 5, 6 or 7 electrons respectively in their outermost shell, and thereby forming an electrovalent compound. मतलब any atom of any metallic element. Let's say example sodium, which has 1 electron in its valence shell. Let's say magnesium, which has 2 electrons in its valence shell. Let's say aluminium, which has 3 electrons in its valence shell. They lose electrons to atoms of non-metallic elements. Let's say this is 5 electrons in its valence shell, that is, let's say nitrogen. Let's say 6 electrons in its valence shell, let's say oxygen, or 7 electrons, let's say chlorine. So these atoms will lose the electrons to these elements, that is non-metallic elements. Means they will donate the electrons to these non-metallic elements and forming the electrovalent compound. After the transfer or donation of the electrons, both the combining atoms acquire the nearest noble gas configuration. While practicing, we will be soon understanding, and the whole thing will be more clear when you will be doing the periodic table. Now metal loses electrons, becomes positively charged ion. They are called cation. These are also the reducing agents. Always remember, metals are reducing agents as well as hydrogen. Though hydrogen is not a metal, but it is a reducing agent. Non-metals gain electrons, becomes negatively charged ion known as anion, which is oxidizing agent. So ion is a charged particle which is formed due to the gain or loss of one or more electrons by an atom. An atom is a metallic element which loses electron readily to form positively charged ion are called electropositive ion or cation, and it is a reducing agent. So sodium, it has 281 electronic configuration. Loses 1 electron, gives you sodium ion having electronic configuration 28. It is called cation, electropositive ion, and it is the reducing agent because it gets oxidized. If you consider the oxidation state, here it is 0 state. Why? Because sodium is not added with anyone, it is single metal, so it is not combined with anyone, or it has 0 valency. This is plus 1 valency. So 0 to plus 1, there is the increase in valency state. So this is called oxidation of sodium. So one which oxidizes itself is a reducing agent, and vice versa. One which reduces itself is an oxidizing agent. This will be more clear when you will do for oxygen. So an atom of a non-metallic element which gains electrons readily to form negatively charged ion are called electronegative ion, anion, or oxidizing agent. So oxygen, electronic configuration 2,6, it takes 2 electron to get the nearest noble gas configuration, which is neon, and it becomes anion O2 minus. So its valency is -2, and here the valency is 0, because you know valency is also called the combining capacity. Here this oxygen is having no one with it, so it has 0 valency. Here oxygen is having the -2 state. So there is a reduction in the valency or the oxidation state. So this is called oxidizing agent, and it gets reduced. Now cation and anion being oppositely charged, they attract each other and form a chemical bond. So this bond formation is due to the electrostatic force of attraction between cation and anion. So it is called electrovalent or ionic bond. Number of electrons that an atom of an element loses or gains. To form an electrovalent bond is called its electrovalency. So here sodium lost 1 electron, so the electrovalency of sodium is 1 plus 1. Oxygen gained 2 electrons, so the electrovalency of oxygen is minus 2. Metals have 1, 2 or 3 electrons in valence shell. They have tendency to lose valence electrons. Metals combine with non-metals which have 5, 6 or 7 electrons in their valence shell. Non-metals have a tendency to gain electrons and form ionic bonds. So bond formed between metal and non-metal are ionic or electrovalent. So why ionic compounds are stable? Because they are formed by ions. So there exists a repulsive force between ions for like charges. Electrostatic force of attraction between opposite charges is much higher. So it makes ionic compounds stable. The examples are sodium chloride, magnesium chloride, calcium oxide, potassium bromide, calcium chloride. These are a few, there are many. Why cesium fluoride is the most ionic compound? Cesium has the highest tendency to lose electrons and fluorine has the highest tendency to gain electrons. They have very high or very strong electrostatic force of attraction. So it is the most ionic compound. This particular portion will be more clear when we will be studying periodic table or periodic properties of elements in due course of time. Now what are the features of ionic bonding? Metal atoms always lose their outer electrons to form the positive ions. Non-metals except hydrogen. Hydrogen loses electron. Non-metals except hydrogen always gain electrons to become negative ions. Ions formed have more stable electron arrangement. Ions formed by losing or gaining, they have more stable electronic arrangement. That of the noble gas nearest to the element concerned. Ionic bond results from the attraction between oppositely charged ions. So here it is the formation of sodium chloride. If you see previous also that sodium has electronic configuration 281. You can see here K shell has 2, L shell has 8 and M shell has 1. Now 1 electron is excess of the stable electronic configuration of the nearest noble gas, that is neon. Neon's configuration is 2,8. Therefore, an atom of sodium shows a tendency to give up 1 electron from its outermost shell to acquire the stable electronic configuration of neon. Neon is 2,8. So after giving up the electron, the sodium is no more electrically neutral. Why? Because sodium previously in this, sodium had 11 electron, so it has 11 proton to become electrically neutral. Now once it loses 1 electron, it has 11 proton and 10 electron. So it is not electrically neutral. So therefore it has net positive charge of +1. So this positively charged atom is called sodium ion and written as Na+, and its electronic configuration is 2,8, which is the same as that of neon. Now in case of chlorine, chlorine's electronic configuration is 2, 8 and 7. It has an electronic configuration with 1 less than its nearest noble gas, that is argon. Argon has electronic configuration 288. Now, chlorine atom shows a tendency to acquire an electron to attain octet in its outermost shell. Therefore, chlorine will have 18 electron once it gains the electron. So an atom of chlorine is electrically neutral as it contains 7 protons in its nucleus and 17 protons in its nucleus and 17 electrons revolving around it. But if it acquires 1 electron from the sodium, it has 18 electron and 17 proton. So it is no longer electrically neutral. So 1 electron is more than the number of proton. So therefore it has a charge of -1 represented as Cl- or chloride ion. So thereby chloride ion will have an octet of electrons in its outermost shell. So its configuration will look like that of argon, that is 288. So ultimately what we are getting? Atom of sodium whose electronic configuration is 281 loses 1 electron to chlorine or transfers 1 electron to chlorine to get the configuration of neon 28, and chlorine accepts the electron from sodium and acquires the configuration of argon. So resulting the formation of sodium chloride. This is the orbital structure of sodium chloride or orbit structure of sodium chloride. Now the cation, that is sodium plus and anion, are attracted towards each other due to the electrical charges or Coulomb forces exist between them and form an ionic compound. Similarly, we have the configuration of magnesium as 282. So outermost orbital of magnesium has 2 electrons, which it donates to 2 different chlorine atoms. So it requires 2 chlorine atoms, and the magnesium can transfer 2 electrons or loses 2 electrons. So its valency is +2. Chlorine as usual accepts 1 electron. So each chlorine accepts 1 plus 1, that is 2 electrons. So these are called anion, and it has the valency of -1. So the ratio of magnesium to chloride ions is 1:2. So the molecular formula of the compound of magnesium chloride is MgCl2. Now take the case of the calcium oxide. Calcium has the electronic configuration as 2882. Once it loses electron, it acquires the structure of argon 288. Oxygen has the electronic configuration of 26. Once it acquires electron from calcium, it gets neon structure, that is O2-. So the nearest noble gas for calcium is argon, nearest noble gas for oxygen is neon. So here is the structure, ultimate structure. Now here only one oxygen atom one oxygen ion with charge -2 is requiring to accept 2 valence electrons donated by the calcium ion atom. The formula of calcium oxide is CaO. Means here the ratio of calcium and oxygen is 1:1. So the formula is CaO. Now what is electron dot symbol or Lewis symbol? Now bond formation by orbit diagram is not so convenient as electrons of only outermost orbits are taking part in the bond formation, as you have seen here. You have seen here, you have seen here also. Only the outermost shell or valence shell is taking part in the reaction. So Lewis gave a concept of dot diagram, which is called electron dot symbol or Lewis symbol or Lewis diagram, electron dot structure, whatever, in which only valence electrons are shown. So electron dot symbol for an atom consists of the symbol of the element surrounded by dots representing the outermost shell electrons. The paired electrons are represented by pair of dots, whereas unpaired electrons in the outermost orbit is represented by a single dot. Now in this case you cannot understand, but in case of the next slide you will be seeing, you can understand. Here you have oxygen. Oxygen has 6 electrons in its outermost shell or valence shell. So 6 can be shown in pairs of 2 to each. So 3 pairs you can show. And for hydrogen it is single electron. Then symbols other than dots such as circles and crosses can be used to distinguish between the electrons of different atoms in a molecule. Now if dots represent the outermost electrons of nitrogen, electronic configuration is 2, 5. See here you can see 1, 2, 3, 4, 5. So there are pairs, 2 pairs, here 3, because you require 3 now, so that's why 3 electrons are placed over here. And crosses are representing electron of hydrogen. Now in ammonia you require 3 hydrogen. So 3 electrons are here and nitrogen's 3 electrons. They are making the pair over here. This is the electron. This is not electrovalent compound. This is an example of covalent compound, but it is shown for the sake of understanding of electron dot structure. If you want to show an ionic compound like sodium chloride, transfer of electron of outermost orbit can be shown by the curved arrow. Now in case of sodium, you have only 1 electron in the outermost shell, and for chlorine you see these are pairs and one is separated. So this will be paired with this electron because electrons move in pair only. So this electron will be pairing with the electron of chlorine. So you are getting Na plus, this is you are showing by this arrow. Na plus Cl minus or NaCl. We will show this. This is the structure. You can see here this electron will be coming here. So chlorine got paired, this electron. Now here in case of magnesium, this goes here with the unpaired electron of chlorine with the unpaired electron of chlorine. So these electrons got paired. In case of calcium oxide, calcium has 2 electrons and oxygen also has 1 electron are separated and you get 2 electrons. Don't put these 2 electrons together. 1 of calcium will go to pair with 1 of oxygen. Likewise Ca plus 2 and O2 minus. Now there is one term called redox reaction. Generally electropositive atoms loses electrons, undergoes oxidation because they are reducing agent. Electronegative atoms, they gain electrons, undergoes reduction and they are oxidizing agents. And this particular reaction is called redox reaction. Now in case of formation of sodium chloride, you see it is 2Na plus Cl2, you get 2Na plus 2Cl minus. So you get 2NaCl if you want to balance. Now what is happening over here? 2Na, this is the half reaction. First we have the formation of 2Na plus Na plus. 2Na, 2 electrons goes off. You can write this way also minus 2e, or you can write 2Na arrow 2Na plus plus 2. You can write both the ways. So 2Na arrow 2Na plus plus 2. So this is the oxidation. Earlier also I told you there is the increase in oxidation state 0 to plus 1. Chlorine accepts 2 electron and becomes chloride ion. So this is reduction 0 to minus 1 because these are not attached with anyone. When they are gaining electron, they get reduced. When it is losing electron, it gets oxidized. So sodium to sodium plus, you are having oxidation. Chlorine to chlorine minus, this is reduction. Now in any reaction, oxidation and reduction will always occur simultaneously because the electrons lost by the reducing agent must be gained by the oxidizing agent. Another equation you can take, zinc plus copper sulfate. Now here you see zinc, here it is not attached with any other element, so its combining capacity or valency is 0. Copper sulfate, copper is plus 2 because sulfate is minus 2. So copper is plus 2. So you get zinc sulfate. Here zinc valency is plus 2 because it is attached with sulfate which is having the valency of minus 2. And copper is not attached with any one, so its valence state is 0. So zinc to zinc plus 2, 0 to plus 2, that is increase, so oxidation. Plus 2 to 0, that is decrease, so it is reduction. So I have shown here how this oxidation and reduction has taken place. These are certain websites I have used. Thank you for your patience hearing. Thank you.